Game on. Okay, we are doing multiplying fractions. All right, we've done adding and subtracting of same denominator fractions. We've done fractions of a quantity. You right?
Yep.
Cool. We're gonna do multiplying fractions now, and in some ways this is actually easier than doing the adding and subtracting of fractions. So let's start with an example. Let's do 1/4 times by 2/3. All right, this. I don't know what you're like. I'm not always very good at estimating the answer in my head. I do need to go through a process here.
Miss Kosh has the same similar thing. Miss Kosh?
Who's Miss
You know her?
No,
Science teacher? Science teacher?
no.
But she does a similar same thing as you with the little thing.
With the little thingy, what's he, and the stuff on the what's it?
Yeah.
Yeah, right.
Your microphone.
Yeah, microphone's working. Anyway, so in the simplest way possible, someone explained to me what do I need to do to actually calculate or evaluate 1/4 multiplied by 2/3. Go on, Lika.
Better the answer, better you have to times the bottom by something than times the top by something.
Do you know what? It's, you're right, but it's probably even easier than that. Mate.
So you do the numerator times numerator.
Good.
And the denominator times the denominator, and then you divide it.
Yeah, good. So we have to pair up the numerators, and they're going to get multiplied together. We pair up the denominators; they're going to get multiplied together. So what we've got is 1 times 2. 2. And we got 4 times 3. 12. We have just done fraction multiplication, and our work here is done.
I
It
didn't
can be
know it's-
Or,
simplified.
very good. It can be simplified. Should it be simplified?
Yes.
Yes, it should. If it can, it should. So, I don't know, what's the common factor?
It could go to 2 over 2.
Oh, not 2
That's
over
a whole
2.
load.
2 is an important number in this, but Valencia.
1 over 6.
Yeah, 1 over 6. 2 and 12, they can both be divided by 2, so we're going to simplify this to 2 into 2 goes 1 time, 2 into 12 goes 6 times. What we've got is 1/6. Are we cool with that?
Yeah, sure.
All right, I'm going to give you another one. Same thing, we're going to just multiply the numerators, multiply the denominators, and then simplify if you can. So let's go for 3/5 times by 5/8. The bit that I did in blue on the previous example, you don't have to show that, but you do need to follow those steps. So just make sure that you're multiplying the top numbers, multiply the bottom numbers, and then simplify if you can. Janie, you got that one written down?
Yeah.
You had a go? Have you had a go? Don't have a go. All right, who can tell me, top row, the numerators, 3 times 5 is, Lily? 15, good job. So 15 is going to be our new numerator. I want to know what our new denominator is. Jenny? 40, good. All right, and our work here is done.
Let's simplify.
Yeah, we can simplify. So should we?
Yeah.
Yes, we should. Lika?
3 over 8.
Yeah, good. 5 is an important number here because 5 goes into 15 and 40. Goes into there 3 times, goes into there 8 times. Just tidy it up a bit. 3 over 8. All right. Cruisy?
Yeah.
Now, it's not the only way that we can do it, but I'm going to show you something different in just a tick. First off, here's one I prepared earlier. I want you to have a quick crack at that one for me. All right, so some of you worked out that that wasn't entirely fun to do, but let's go through the process here. So 3 times 8 equals 24, good, and 4 21s, 84. Right, they're not horrible numbers, but when it comes down to actually simplifying that, that's not the nicest thing to do. What do you know for certain, like 24 and 84, what do they have in common? Lika?
They both 24 goes into 84 3 times.
It will go 3 times, but not exactly 3 times. So that one doesn't help us too much in this case. Austin?
Both even and 10 fourths.
Yeah, good. So they are both even, which means if we wanted to, we could divide them both by 2. But you're saying you can also divide them by 4. All right, let's do that first. So 24 divided by 4 is 6. 84 divided by 4 is 21. Yeah, cool. All right, and we're done. No, we're not. Why not? Lily, what would you do? We can simplify it some more. Good. So 6 divided by 3, that would be a useful one, because 21 can also be divided by 3. So we end up with 2/7. So I have a question for you. Who got the 24 over 84 bit? Too easy. Cool. All right, good. Who managed to simplify it all the way down to 2/7? I saw a couple of people did, which is cool, but it's not the ideal way to do it. Hey, all right. So I reckon this is like the first way of doing things, like the way we did the examples on the previous page. I want to show you an alternative, exactly the same question. For you guys here, just put your pens down for a sec. I want to show you something different. First off, this is exactly the same question, right? And in some ways, we already know what the answer is going to be. So there's no surprises here. But I just wanted to say that after we multiply the 3 and the 8, we're going to have a 24 over 84. That 24 is made up of all the things that we used to multiply together. So what if we could do some simplifying before we did the multiplying? The 3 and the 8 are going to combine to make our new numerator. The 4 and the 21 are going to combine to make our new denominator. We can take bits and pieces from our numerator and denominator and cancel them out now. So have a look for me. Anything in the top row that has something in common with something in the bottom row. Lika?
4 and 8.
4 and 8. What do they have in common?
They both go into 2. They both go into 4.
Yeah, I'd just flip it around. I'd say 4 and 2 both go into both of those. So we could say 4 goes into 4 1 time, 4 goes into 8 2 times. All right. What else? Is there anything else that we can do? Valencia, what would you do?
Divide 3 and 21
By 3. Okay, so 3 goes into 3 1 time, 3 goes into 21 7 times. Is there anything else that we can simplify? No, okay. So now we multiply what's left of our numerators. We've only got a 1 here and a 2. 1 times 2? 2. 1 times 7?
7.
Which way is easier?
That way.
This way? The other one is the first way, this being like method number 2. The first method is easier, but only if the fractions are easy. If you get fractions that are a little bit awkward or a little bit messy, it's worthwhile trying to do some simplifying first before you end up with really big, ugly numbers. Dealing with some smallish, ugly numbers is manageable. You don't want to be dealing with 24 over 84 and fumbling your way through simplifying to get to the end. All right.